So it was the limit as x approaches a of f of x minus f of a all over x minus a. So this gave us a number answer every time. So our number was 10. Our number was negative 1/3. It was always a number answer, right? There is a way that we can do the limit definition of derivative where it applies to the whole entire function. Okay? So let's look at this here at my Desmos graph. So I have made this more complicated for you here. So let's make this show up a little bit bigger. All right, so what I have here is I still have my x f of x point. Then I named this other point, and I did not put enough parentheses, and it looks bad. There, let's put another parentheses right there so it's proper there. I named my other point x plus h, f of x plus h. Okay, so x is this point wherever I have chosen this to be. And then this point on the x-axis is x plus h. So I've got this little green line right here, and that is h. Right? That's how far we are away from x. So I want the same thing to happen. I want one point to get closer and closer and closer to the other. Right? What happens to the length of that green line right there as I get closer and closer and closer and closer to that point? It gets smaller and smaller and smaller and smaller. What does it approach? What does the length of h approach? It approaches 0, right? It's getting shorter and shorter and shorter until it would be, if I could get all the way to that point, the dot's moving, but that green line is, it's shorter and shorter and shorter. It's getting closer and closer and closer to 0. Okay, so it's the same idea, but I have labeled these differently. Instead of having a being my fixed point, I've got an x f of x, and then I've got this x plus h f of x plus h. So when h gets smaller and smaller and smaller, then as h gets smaller, my point right here will get closer and closer to the other point. So I'm getting closer and closer to having a tangent line. Okay, so it is similar to what we did yesterday, but this time our points are, we still have x f of x, but our other point is going to be x plus h f of x plus h. And a lot of times, it depends. Our textbook does not use an h. Our textbook uses a delta x. So if you look at any of the examples in the book, or if you watch what they've showed you on those videos, it's going to have a delta x there instead of an h. I'll write it both ways for you. So if I do the slope formula for this, it would be f of x plus h minus f of x, those are my y coordinates that I'm subtracting, divided by x plus h minus x. And what I'm doing here is I want that h, that difference between the x and the x plus h, I want it to get smaller and smaller and smaller. It's that little green line that I just showed you. We want that to get smaller and smaller and smaller because we're getting closer and closer to h. So this will be the limit as h approaches 0. Now, look at the denominator. Do I have anything that could simplify there? The x's are going to cancel each other out. So the more concise way to write this is limit as h approaches 0 of f of x plus h minus f of x all over h. Now, our textbook is not going to use a h. Our textbook is going to do this. They're going to use delta x in place of that h. So it's going to be f of x plus delta x minus f of x all over delta x. So these two right here, or these right here, they're just in place of the h. On AP, I have seen them using an H more often, or a letter there. It could be any letter. It doesn't have to be an H, but it's just one that's typically used. I've been seeing them use the H more often, so I'm going to do that. Just know if you look at your book, they're using delta x, which is your change in x. And delta x is not delta times x. It is one single variable whenever you have it there. It's just like an H. So let's look at what happens for these problems. Okay, and this is one that you may want to put a box around, put a star beside. You need to have that one memorized as well. This is our limit definition of a derivative for any point. Up here, it was just at one single point. Okay, so an example of a type of problem where you're going to have to use this is if they ask you to find the derivative of f of x equals x squared and they don't give you a specific point. We can't use the limit definition of derivative at a point here because they didn't give us the point. So it would not work. So we have to, for this right now, Luke already knows the answer to this, I bet. Maybe. You know the answer to this? It's 2x. Jeremy already knows it.
Oh, because it's the one.
They've already learned the secrets. The answer's 2x. It's going to be super easy once you learn this shortcut, like crazy easy. But right now I'm making you do a limit definition. And today I had some mercy on those of you that just had numbers written down. But tomorrow I will not. If your homework paper does not have limit definition of derivative, at least attempted on it, then you are not going to get credit for that homework. Okay, so we got to at least try it right now. I promise I'm going to teach you the shortcut soon. But we got to at least try it. So the limit definition of a derivative for any point is limit as h approaches 0 of f of x plus h minus f of x all over h. So to plug into this equation, it's very similar to what we were doing last night. The difference is we're going to have a whole lot more x's and not as many numbers on these. I need to find f of x plus h. I'm going to do that over here to the side, f of x plus h. So what I'm doing when I'm finding f of x plus h is I'm taking x plus h and I'm plugging it in for the x. So it is going to be x plus h squared. And to do x plus h squared, I need to square double square for that, or you can write it out twice and multiply it that way. So I'll have x squared. What do I get for my middle term? 2xh, and then h squared. So that is f of x plus h. That goes right here. Okay, so I'm going to do the limit as h approaches 0 of x squared plus 2xh plus h. So that's this part. I still have to do minus f of x. What is f of x for this problem? Oh, this, yes, thank you. And the f of x, what is it for this problem? It's just x squared, right? So this right here, our x squared is our f of x. That goes right here. And it's all going to be over h. Now, these are like the delta x problems that you were doing for limits. The reason that they were giving you those delta x problems in limits was to prepare you for doing these problems. So what should happen with delta x problems is everything without an h, or the delta x, should cancel out. So that x squared and the negative x squared cancels here. And so we are left with 2xh plus h squared all over h. I should have an h in every term. I can factor out that h. So it will look like this, limit as h approaches 0 of h times 2x plus h all over h. Okay, here. All right, h's cancel. Right here, h divided by h is just 1, so that's going to go away. Then we're plugging in 0 for what? H, not for x, for h. So the x stays, and the h is replaced with a 0, and 2x plus 0 is 2x. So we would say f prime of x, the derivative of x, or derivative of f here is 2x. So our answer is going to have an x with it. Now, if I want to know the derivative at a point, all I have to do now, like if I want to know f prime of 3, all I've got to do is plug in 2 times 3, which is 6. If I want to know f prime of negative 4, I plug in 2 times negative 4, which is negative 8. Okay, there's a major advantage to having this if you need to know it at many points. I think the work for it is more difficult than what we did last night, than the f of x minus f of a definition. But it gives you a formula that can be used for all types of questions. Okay, questions here? All right. All right, let's try another one. X to the third plus 2x. That should be a f prime. Oh, no, that's just the f of x. Yeah, we're finding f prime of x if f of x equals x to the third plus 2x. That f prime of x, that just means derivative of f of x, right? So slope of the tangent line of f of x is what we're looking for. This one's harder because the equation is harder. Now, Jeremy, what's the answer going to be? That's the answer. That's the answer we should get. If you know the shortcut, you might be figuring it out, maybe. I think you know it for plugging in numbers. Yeah. I think you've been plugging in numbers to it. Because if you plugged in 1 to that, you would get 5. Yeah. Well, what else do you plug in? Nothing. Like right now we're just taking the derivative and we're not plugging a number into it. So shortcut wise, it is that easy once we learn the shortcut. But we got to go through this pain first before we can learn what the shortcut is. We got to do limit as h approaches 0 of f of x plus h minus f of x all over h. That's the rule that we're following, right? That's our limit definition of derivative. F prime of x is going to equal this. If you don't write that, that's fine. This is just the definition. I'm just writing it to be very clear about what's happening here. So, oh gosh, actually, let's see. I'm going to go over to the side because this is not going to be easy. I've got to find f of x plus h, which means I'm taking x plus h and I'm plugging it in for both of those x's. Okay? So I've got x plus h cubed plus 2 times x plus h. X plus h cubed, I cannot square double square that. That's not a square. X plus h cubed means x plus h times x plus h times x plus h. Alright, and then this 2x plus h, I could go ahead and distribute there, 2x plus h. So I would have to multiply 2 of these together first, which is a square double square for that, because you're just multiplying x plus h times x plus h. So that's going to give me x squared plus 2xh plus h squared. That's what I'm going to get if I multiply like these two together, but I still have an x plus h here. Oh, I messed up on that, didn't I? What have I messed up on? You might see my mistake.
2h plus 2.
That should be a 2h right there. Okay. So then I've got to distribute here. I've got to distribute that x. Oh, good gracious. That's going to be x to the third plus 2x squared h plus xh squared. And then I've got to distribute the h, which will give me plus x squared h plus 2xh squared plus h to the third. That's all of this stuff right here. I still got the plus 2x plus 2h over here. It's not too bad. I mean, it's not that bad, but it's easy to mess up on these things. Just one sign off or one number wrong, and it's easy to miss. So, yeah, on this one it's easier because there's only positives here. If you throw in some minuses, it can make it trickier. All right, so x to the third. I've got a 2x squared h and another x squared h here, so that's going to give me plus 3x squared h. Then I've got xh squared and a 2xh squared. That is going to give me 3xh squared. See how those are different there where the square is at? And then plus my h cubed. And then I've got a plus 2. I've messed something. No, I've not messed something up. Plus 2x plus 2h. Here's one of the reasons why this is so stinking hard. All this that I have done right here, all of this mess right here is just this part. Just that part. So we're not even done. That's just like a little piece of it, right? The algebra on this is really tedious. Don't worry, we don't have to do it forever. Especially since Jeremy did this in his head in just a few seconds, right? So we're doing limit as h approaches 0 of all of this stuff. X cubed plus 3x squared h plus 3x h squared plus h cubed plus 2x plus 2h minus minus f of x. So make sure you put parentheses here. We got x cubed plus 2x. All of this over h. We must have parentheses there, or we could go ahead and distribute that negative, which will make this a minus x, and we're distributing the negative over here, which makes that a minus 2x, and because I do not want to write that over again, I'm just going to make those both negatives there. And what should happen is this stuff on the end, that x to the third and the negative x to the third and negative 2x, it should cancel with your terms over here. If it does not, you've probably messed up somewhere. So we have this negative x cubed cancels with that x cubed. And I have a negative 2x cancels with this positive 2x right here. So if you have done it correctly, everything should cancel except for stuff that still has an h. And you can see all of these have an h, so I'm going to factor out a h. And I'll have 3x squared plus 3xh plus h squared plus 2 all over h. I'm going to keep my limit notation because I have not plugged 0 in for h yet. Okay, h's are going to cancel here. And so at this point, once the h's cancel, I'm going to plug in 0 for what letter? H. So I'm going to do 3x squared plus 3x times 0 plus 0 squared plus 2. What happens to any of those terms that have the 0 with them? They just equal 0. Oh, here finally is our answer, 3x squared plus 2. You cannot use the shortcut yet. Like I said, if you don't know the shortcut, you might not even want to learn the shortcut until next week when we start doing it, because it just makes you angry that you got to do all that for something that you could do in your head. Okay, so this is our derivative. It gives us the slope of the line at any, of the tangent line at any point. So if I want to know the slope of the tangent line at 0, I would plug in 0. If I want to know the slope of the tangent line at 4, I'd plug in 4. All right, questions? You can use this on the homework that we had last night. I don't know why you would want to. This is a little bit easier to do the other way that we did last night. But, like, you could use this to do the homework last night. So if this question had asked to find, instead of f prime of x, f prime of 2, you could do it the way we did last night. Or you could do it the way we did tonight and just plug in 2 into your answer. Actually, you would probably have a little trouble with that one, because you'd have to factor that. Yeah, you'd have to do synthetic division. You might have to do that one this way, because you wouldn't be able to factor it. But let's move on. All right, here's some new notation for you. This d over dx means the derivative with respect to x of whatever is inside of those brackets there. The derivatives we have already done have also been with respect to x. It really is not going to matter that much that it's with respect to x until we get to related rates later. So for right now, you don't have to think too much about that. Just know it's asking you to take the derivative of this. Currently, the only way we know how to take the derivative of something like this is to use our limit definition of a derivative. Jeremy cannot do this one, I don't think. I don't think so, yeah. So, shortcut, there is a rule for this, and we will learn it, but it's not as easy as the really simple power rule that Jeremy knows. So, you're going to be stuck. You're going to have to do it this way for this particular problem right now. Till we get to like 2.6, I think maybe is where we learn how to do this one. The shorter way. So, section 2.6. We're in 2.2 right now. 2.2. 2.6. Yeah. We'll learn the shortcut before we'll learn the one that Jeremy knows before we learn this one though. This is actually no, this one may not show up until unit 3. Because that's not this one might not show up until unit 3. So we're stuck using the limit definition for a little bit. So that limit definition, limit as x approach, h approaches 0 of f of x plus h minus f of x over h. So for this problem, this is actually a little, this one is harder to solve once you plug it in, but a lot easier on this f of x plus h part. F of x plus h is just square root of x plus h plus 1. Because we are just taking our x plus h and plugging it in right there for that x. So it's that initial part's a little bit easier. The second part might be harder. So we have got square root of x plus h plus 1 minus just f of x, which is square root of x plus 1 all over h. So just to make sure everybody's with us where we're at. F of x plus h, that's this right here. We plugged it in for the f of x plus h. F of x is just, in this case, what we're taking the derivative of. So that's x plus 1, or square root of x plus 1. Alright, how do I solve that? If you plug in 0, you get square root of x plus 1 minus square root of x plus 1, which is 0 over 0. What's the fancy name for it? Conjugate. The conjugate. So you might be thinking complex conjugate, which is when we have i's with it. This doesn't have an I, so we wouldn't call it complex, just conjugate.
It's
So
pretty complex.
it is still pretty complex. Possibly worse than the ones that do have the i's, actually, I would argue. But the only thing we change is the negative in the middle turns to a plus sign. And make sure that you multiply this on the top and the bottom of the fraction. Alright, so if we multiply this together, we got to multiply those first two together. Square root of x plus h plus 1 times square root of x plus h plus 1 is just x plus h plus 1. And then we will multiply the outside and the inside, but we'll get a positive and a negative, and they will cancel, which is the reason we chose the conjugate in the first place, right? We wanted that to happen. And then we have to multiply the square root of x plus 1 times the square root of x plus 1, which we will get x plus 1 for that, but make sure you got parentheses around it, because that negative goes with both of those. And then on the bottom, we've got h times all of this mess right here. And don't try to multiply that together because you want something to cancel. So you don't want to, you would just have to factor it back out if you multiplied it together. Alright, so I'm going to go ahead and distribute this negative right here. I'm going to make that a minus and this one a minus also. And I'm going to start doing my canceling. So I've got x and negative x, those cancel. I've got a 1 and a negative 1, those cancel. So now I've just got limit as h approaches 0 of h over h times square root of x plus h plus 1 plus square root of x plus 1. And what else cancels here? Those h's are gone. Now, since nothing's left in the top, make sure you still got a 1 up there. So once the h's cancel, that's usually when you're going to plug in. What am I plugging 0 in for? H, not the x's, the h's. Alright, so I'm going to have square root of x plus 0 plus 1 plus square root of x plus 1. Which gives me 1 over the square root of x plus 1 plus the square root of x plus 1. Now, if it's free response, you can leave it here. You can even leave it with that 0 in the middle of it. It's fine. But if it's multiple choice, they're not going to leave the answer like this. So let's try to simplify that. What? I could add those square roots together. What's it going to give me? 2 square root of x plus 1. You're not multiplying them, so it's not going to be like x plus 1. You got one of them here, you got one of them here, which gives you 2 square root of x plus 1. And that is your answer. It's still probably easier than limit definition, but you have to have what we call the power rule to do that one. No, not power rule. Chain rule for that one. Chain rule. Yes. Yes, the 0, these are h approaches 0. So we're plugging in 0 for the h right there. So most of these are going to have an x left in the answer. So we don't plug in for that x. Occasionally, if you have a real simple one, the x's all cancel out and you just get a number for your answer. But most of them will have x's left. If you wanted to, you could say, on this one I would not because of the notation they used at the beginning. If you want, you could say this is equal to all of our work that we're doing. You could do like a set of equal signs. I would not call that like f prime of x because they didn't call it f of x in the beginning. If they had called it f of x and asked you to find f prime, then you would maybe want to state that at the end. What I would do, though, is I would just, work this out, string of equal signs. Here's your answer at the end. There is some dispute in the AP Calculus world of whether or not you should circle your answers. I can see it going either way. Some teachers say always circle your answers so that you've made it clear what your answer is and the grader can find it on the paper. Other teachers say never circle your answers because let's say that you over here then decided that you were going to plug in 0 and you got 1 over 2 square root of 0 plus 1, which is 1 over 2. And that was really what you were saying your answer was. If you don't circle it, they may assume that scratch work and they might not take off for it. But if you circle it, they're going to think that they're going to read that as you said that was the answer. And you weren't supposed to plug in 0 for the x on that, so that would be wrong. So
they're just saying don't circle it because it's circle something else.
Yeah, if you have the right answer, but you went too far or you did something wrong after that, maybe they'll just give you credit for the answer and not realize that you meant for this other thing to be the answer. So I don't know. I can see the argument either way. If your work's really messy, circling your answer might be helpful because they can pick it out and know like the order of your work a little better. I could see it either way. I like to circle my answers when I do notes so that you very clearly know where we're stopping and where the answer is at. But you guys can decide what is right for you. All right, we're going to do one more question. We're not going to do this last one right here. Is that the last one? No. Oh gosh. Which one have I got? Okay, those are quick. We can do those quick. We're probably not going to do this normal line stuff. We can do without it. I left it in there. They don't put that on the exam anymore, so we can live without that. Okay, so actually, this is point slope practice. Let's just do the first one. This is super quick, okay? This is math 1 right here. Write the equation of a line that has a slope of 4 and passes through the point 6, negative 2. All right, this is math 1. I taught you guys point slope the other day. It is, your slope goes right here. You got x minus x1 plus y1 here. So for this problem here, your slope would be 4. Your x1 would be 6. Your y1 would be negative 2. So if you want to write the equation of the line here, you would do y equals 4 times x minus 6 minus 2. Okay? You could simplify it if you want, but unless they ask you for like a y-intercept or something, don't. Just leave it, right? You can just leave it like that. All right? So that's just a review point slope form. Now, let's look at a calculus question. Write the equation of the line tangent to f of x equals square root of x minus 2 at x equals 3. Okay? To write the equation of the line, you need two things. You need the point, and you need the slope at that point. Okay? How do I find the point on the line? I know I'm looking at x equals 3, so I know my point is going to be 3 something. How do I find the y-coordinate? Just plug it in. So your point, we're just finding f of 3, right? So if I do f of 3, that is just plugging in 3, square root of 3 minus 2, which is the square root of 1, which just equals 1. So my point for this would be 3, 1. There's the coordinates of the point. How do I find the slope of the tangent line at 3?